Good morning, sir. I am Sneha from MTech first year ECE with roll number MTAC 2105. I'll be explaining the image capturing system in camera and eye. So, how does a camera work? Basically, a camera works with the help of lens. A camera lens takes all the light rays bouncing around and uses glass to redirect them to a single point, creating a sharp object. When all of those light traces meet back together on a digital camera sensor or a piece of film, they create a sharp object. If the light doesn't meet at the right point, the image will look blurry or out of focus. A lens focusing system moves the glass piece closer or further from the sensor or film, allowing the photographer to adjust the lens so that the object is sharp. Here, distance also plays an important role in how camera lenses are able to zoom in. When the front piece of glass moves farther away from the camera sensors, objects become closer. Focal length is a measurement of the distance between where the light rays first hit the lens and where they reach the camera sensor. Here, we can see a diagram about how the camera captures an object. Here, we can see the lens, film, and real image. Now, how does now we will learn about the film and digital sensors. In camera for image capturing, the film and the sensors play a very important role. Here, film is made up of light sensitive materials. When those materials are hit with light from the lens, they capture the shape of the object and details like how much light is coming off to them. In the dark room, the film that was exposed to the light is again put in a series of chemical baths to eventually create the image. This was done in the old back days. Now, here in the digital cameras, the sensors play a very important role. A digital camera sensors move more closely resembles a solar panel than a strip of film. In olden days, generally to capture an image in a sensor in a camera, a film is used. But in nowadays, for the digital cameras, we will use the digital camera sensors. Generally, sensor is a solar panel, then simply a strip of film. Here, each sensor is divided up into millions of red, green, and blue pixels. That is the megapixel. When light hits the pixel, the sensor converts its energy, and a computer built inside of the sensors reads just how much energy is being produced. Here, so how does the digital cameras works? It works exactly in this way. When the light hits the pixel, the sensor converts its energy, and the computer built inside of the camera reads just how much energy is being produced. Measuring how much energy each pixel has allowed the sensor to determine what areas of the image are light and dark. And since each pixel has a color value, the camera's computer is able to estimate the colors in the scene by looking at what other nearby pixels register. Putting the information from all the pixels together, the computer is able to approximate the shapes and colors in the scene. Now, when we go to the image capturing system in the eye, generally the in the eye, the pupil allows light to enter the eye. It appears as the dark because of the observing pigments in the retina. The pupil of the eye contracts when exposed to bright light. As when we enter suddenly into the sun, the pupil becomes smaller. This is because to reduce the amount of the light that falls on the retina. Since suddenly when so much of light falls on the retina is very sensitive, so it can't hold it. So the pupil of the eye becomes contracts. It contracts with the help of the iris. However, as time passes, the retina adopts to the new level of the sunlight or brightness, and the pupil returns to its original size. Here, the circular muscle iris controls the size of the pupil so that more or less light, depending on the condition, is allowed to enter the eye. Here is the diagram of the horizontal section of our human eye. Here we can see the cornea, iris, lens, and retina. Retina is the innermost surface of the eye where we get the image of an object. Cornea is the first and most powerful lens of the optical system of the eye and allows, together with the crystalline lens, the production of a sharp image at the retinical photoreceptor level. The cornea and the lens act together like a camera lens to focus an image on the retina at the backside of the eye, which acts like a film. So here we can see the similarities between the eye and a camera. So the cornea and the lens act as the lens of the camera, whereas the retina of the eye acts as the film of the camera. So generally the distance between the center of the lens and the retina varies from approximately 17 mm to about 14 mm. So an how does our human eye capture an image? Generally, first the light passes through the cornea. Some of the light enters the eye through an opening called the pupil. Next, the iris controls how much light the pupil lets in. Now, next, the light passes through the lens, a clear inner part of the eye. The lens works together with the cornea to focus light correctly on the retina. So, when the light hits the retina is a light sensitive layer of tissue at the back of the eye. Special cells called photoreceptors turn the light into electrical signals. So, inside the retina, there are special cells called photoreceptors which turn the light that falls on the retina into the electrical signals. These electrical signals travels from the retina through the optic nerve to the brain. Then the brain turns the signals into the image you see. So generally, what are these photoreceptors? These are called as cones and rods. Generally, the cones in the human eye are up to 6 to 7 million. They are located primarily in the central part of the retina and are highly sensitive to the color. So humans can resolve fine details with these cones largely because each one is connected to its own nerve end. Cone vision is called as bright light vision, whereas the number of rods is 75 to 150 million, which is large more than the number of cones. Here, and these rods are distributed over the retinal surface. Rods serve to give a general overall picture of the field of view. So this phenomena is called as dim light vision. So because of cones, we'll get a bright light vision, whereas because of rods, we'll get a dim light vision. So this is how the our human eye captures a image using the retina and the photoreceptors. So these are the references I have taken. This is the above is the link that I have taken from the Google, and here it is the digital image processing book. Thank you.